All right, good evening, students. I welcome you for a very important session on transition elements. I already have given you very important and vital questions which are important for all papers anywhere. What we were talking is the chemical reactivity of the transition elements related with their standard electrode potential value, students. This is a very important question. Again and again, I have to repeat it because there is something very important for every paper. I am telling you, what we told you will only give few minutes to explain to you. I have said to you, students, that the chemical reactivity of the transition elements, chemical reactivity of the transition elements, which we were talking about mainly 3D series. What I been talking of 3D series, students, 3D series. This is very much related with their standard reduction potential values. And questions are going to be asked. 100% there will be questions on the standard electrode potential values, which we have shown you in the table how they were calculated, and we have also shown you two things: standard electrode potential. Then we have also talked of redox couple. What do
Yes,
you mean by
sir.
couple, student? What we have given you the values M2 to M values E naught. Did we give the values E naught? So when M2, what it means? M2 aqueous plus 2 electrons gives this. These values we gave you.
Yes, sir.
Standard reduction potential. These are called standard reduction potential values. We have given these values. Now, when I talked of redox couple, student, redox couple means that I was talking about M3 to M2 plus values. This is a value of the redox E not redox values. So a couple is very important because there are going to be questions, student. You will find what we observed, what we found, students, in the 3D series, that in the many of these metals were dissolving in mineral acids. Many of these are metals, they dissolve in mineral acids like HCl, mineral acids.
Yes, sir.
uh, but few noble do not react with mineral acid. For example, which are those noble which do not react with mineral acid? Can you name, students? Now question answer session has already started with me. Can you name those which are noble, which do not react with mineral acids? What are those, students? You are aware that in the transition metal series you have 3D, 4D, 5D. You have certain metals which are noble metals. They are not going to be reacting with the acids. Even they don't even react with concentrated nitric acid, which is a strong oxidizing agent also. Dilute HCl is a normal acid. It is not a strong oxidizing agent, but then concentrated nitric acid is a strong acid. Can you name those few noble metals, students? What are those?
Uh,
Gold.
Sir, copper,
Copper
silver.
will react with concentrated acids, not with dilute, but main which are gold, platinum. You are aware of
And
those.
yes, sir, gold and platinum.
And one more could be there. Lowest to the electrode potential values you have seen noble metals. They, you know that they react with aqua regia only. They react with aqua regia only. So there are the series, you see, what we find, and the metals of the first transition series are more reactive. Metals of the first transition series. What are first transition series, student? Answer my question. What are first transition series? Which one I am talking about?
3D series.
3D series. Okay. The metals of the first transition are more reactive than other series that another important point is that, students, titanium and vanadium passive to dilute non-oxidizing acids. What is happening? Titanium and vanadium are passive to dilute non-oxidizing acids. Can you tell me what is a non-oxidizing acid? Every time I write something, a question is there. Non-oxidizing agent. What is non-oxidizing acids? Now I am giving you like HCl. HCl. HCl is not an oxidizing, but nitric acid is a strong oxidizing agent. You know about that. So further important point to note was that where questions are coming questions are coming students, which we have shown you the values also, the reactivity and electrode potential values. Again and again I scratch my head because the question require thinking and thinking, and just one word answer is there or one line, and if you don't do that then it is over. So either you get 4 plus in medical or 1 in board. It depends what you are writing. So what we observed, what we found students, the E naught values of, can you tell me which elements have more negative E naught values? Give me the name of the elements which have more negative E naught values, students. We have done this in the previous lecture, students. Give me the name of the three elements which have more negative E naught values. Here we are testing how much mind you can use, students.
Uh,
Keep on
Mn.
applying your mind. You see that more we do the things, more it is retained in your mind. And there are reasons for everything we are doing, because there will be questions in the paper. You are aware of manganese, nickel, and zinc. I talked of three elements.
Zinc.
These values were more negative, student. More negative values were there. Why? And what was the reason for that, student? What is the reason for this? Why E naught value of Mn2 to Mn is more negative? Nickel 2 plus 2, nickel more negative. Zinc 2 plus 2, zinc more negative. That's what I am talking about. Values are more
Yes, sir.
negative. That's what you are saying.
Yes, sir.
Okay, I give you 30 seconds to answer this question. Why? How many times this question has been asked? You know about it many times. What is your answer? What is your answer? What did I answer?
Sir, because in Mn2 plus we have half filled
Table
D
3D5
subshell
configuration. What is the answer in nickel?
3D5.
What is the answer for nickel 2 plus 2? Nickel, students.
Sir, for nickel we have very high enthalpy of
Hydration.
hydration.
That is the only word they want in exam, student. High hydration, negative enthalpy. Okay, got it. Why I am talking of these things? What is the answer for zinc, students?
So it has fully filled D subshell 3D10.
3D10 stable. All right. The question answered. No more is required. How do we answer the question? You can see now that there is nothing to write more than that. Nothing to write more than this, students. Further, he is now coming to another important point, student. When I talk of a redox couple, student, this is a question for the paper. Redox couple, redox couple. What redox couple I'm talking of, students? You know about it. I'm talking of M3. I'm talking of M3 to M2 ions, student. Everything is aqueous. Everything is aqueous. Now we are saying what we are saying, student. Titanium 2 plus, titanium 2 plus, vanadium 2 plus, chromium 2 plus. Tell me they are strong reducing agents or oxidizing agent? Strong reducing agent or oxidizing agent? Now the couple story starts. Couple story starts. What I am talking of, student? What I am talking? Where is titanium 3 plus? What I am talking is titanium 3 plus to titanium 2 plus. What is the value of this? Tell me what is the value of this given in the table? Why did I give table? Titanium
It
3
is
to minus.
minus 0.37.
Okay. What is the value for V3 plus 2V2 plus what is the value of this, student?
It is minus 0.26.
Minus 0.26. They are in volts. Okay. What is the value of chromium 3 plus 2, chromium 2 plus?
Minus 0.41.
Minus 0.41. Is it a redox couple? Yes or no?
Yes, sir.
Okay, redox couple. Now the very important hot question for the paper. Hot question for the paper. Hot question for the paper. You see how the questions are framed. Now, what are they? Oxidizing or reducing agents?
Sir, they are reducing agents.
They are the strongest reducing agents because student 30 seconds. These values are
Sir,
negative.
because they
Negative.
have E naught negative values.
So what will happen if they gain electron negative? So but other if they lose electron, so it becomes positive.
Positive.
Standard oxidation potential positive. So they will not gain, they will lose electron. They will go from 2 plus 2, 3 plus state, 2 plus 2, 3 plus state. That means titanium, what you are saying, student, what you are saying that I have to apply my mind for everything. It is not an easy thing. I have to understand. I can't hurry up. I can't hurry up. You are saying like this. What is this value? I have to pay attention. Minus
Minus
0.3. So
0.37.
this is not going to happen. It will not gain electron, but reverse will happen. Therefore, it will give electron. If it gives electron, it is oxidized. It is oxidized. If it is oxidized, then it is a reducing agent. It is a reducing. Okay?
Yes, sir.
Am I cramming anything?
No, sir.
फिर क्या can I do rattebaji? And one student told me, sir, how will I mug this value? I said, who told you to mug this value? He says, oh, well, that is what we do in our school. What I am talking about. Are, we have to understand everything. Otherwise, our question answer can never be right, and you will lose 4 marks in your competition papers. That is the end of the selection of the students. When you do mistakes, it is over. You have to think before you answer the question again and again. I repeat the same thing, student. If I don't understand, how will I do it? Okay, here you find that these two, what I have written, student, titanium 2 plus vanadium 2 plus chromium 2 plus, they will act as
Reducing agents.
strong reducing
Strongest
agent.
reducing agents.
Strong reducing agent. I hope we have registered that in our mind, student. In our mind, student. Okay. So
Yes,
far,
sir.
so good. The session is very important with me. You will keep on interacting with me, student. You will keep on applying your mind, student. Keep the energy levels high, and you eat some glucose before you come to my class, student, because there is a question answer session all that time, student, all that times. So further, now I am talking of Mn3 plus to Mn2 plus, student. Mn2 plus, and I am talking of cobalt 3 plus to cobalt 2 plus. What are the values of these, students?
It is 1.57 for manganese.
Plus 1.57. And what is this value?
For cobalt, it is plus 1.97.
Tell me, they will act as oxidizing or reducing agents.
Sir, they will act as oxidizing agents.
Which oxidation state will act as an oxidizing agent? Mn3 plus
Mn3 plus.
and cobalt 3 plus.
Cobalt 3 plus.
They are strongest.
Oxidizing agents.
Okay, registered, noted it down.
Yes, sir.
Question has been asked in redox couple. Expected question. CBSC and all competition. CBSC and all competition. So what we try to show to you, student, how these values are important for us. What values I am talking about? Standard reduction potential values will tell us about the reactivity of these elements. And they are more reactive means more negative value means more reactive, more negative more reactive. They are less reactive than which elements? These elements are less reactive than which block elements?
Uh, these S block.
S
S
block
block.
element, because S block elements are more negative standard reduction potential. Yes or no?
Yes, sir.
I will do a mistake when I say something. Pay attention again and again. I say, students, pay attention, or we are out of the exam. Life is based on pay attention. Zero attention. If attention is not there, what I am answering, I am not in any exam. I am failing. That's all. You want to succeed, you have no choice. Okay, so far so good, student. We have been trying to come with so many questions, students. So many questions are there, students. Dekho, let me put one more thing there. Let me put one more thing there. see that how do we decide the stability of the oxidation state, student? Stability of the oxidation states. Uh, how we decide that, student? Let me just give one question which has been asked again. It came to my mind, so let me take 1 minute for you. So many questions are being discussed. Be careful because anything can be asked, student. So if question is asked, I will put it in my lecture so you can see them later on also once you get the recorded. What question was given, student? What question was given in the paper, student? What question is given? If I don't think, I am also out. Let me tell you what he says. Copper plus student aqueous to copper. E naught value is plus 0.52 volt. Then I am saying copper 2 plus aqueous plus E naught is equal to copper S. E naught value is 0.34 volt. 0.34 volt. Tell he question is which oxidation state of copper is more stable? Which oxidation state of copper is more stable? You have 30 seconds, students. Which is more stable, students?
Sir, copper 2 plus state is more stable,
More stable. Because this value is less
less
positive as
positive
compared to this. These
than
are positive
E not
values.
value.
Positive.
Yes, sir.
Okay, student, you get 4 marks for the examination. And copper 2 plus aqueous is more stable than copper plus aqueous. See that the story, how do questions are framed in the paper. That's some idea of this. And unless I do all these questions, then what I will learn? Nothing. Okay. So we can proceed further. You have a good catch of all this. These are some of the most important questions which were given to you, students. And now we are coming to trends in the stability of the higher oxidation state, stand-in stability of higher oxidation state. Student, uh, what are these compounds which are there, students, which I have given a table? This table is not taken from a book particularly, because whatever table is given is based on the facts and whatever they have seen trends in the stability of higher oxidation state. These are transition metal halides.
Yes, sir.
Okay, now you are with me. You are with me. Halides. What is X? X is
Hello.
FClVr or I,
SCBR, I.
students? Are
Yes,
we
sir.
both sure?
Yes, sir.
Okay, yes, sir. Then you can see that oxidation state I have shown plus 6, plus 5, plus 4, plus 3, plus 2. And I have not shown the first thing. Plus 7 oxidation I have not shown in the halides. Not shown in halides. Did I show it?
No, sir.
This compound doesn't exist, so there is not in the table. This table is based on the I mean whatever compounds are existing, they have taken that
Okay.
and shown it in the table as given by NCRT book table. So what do you mean by table? I said let me understand the table, or I can just say, oh, what I have to do with it. Then there is a question in it, student, for your papers. Now plus 7 is not shown, but you know what is the maximum oxidation state? I shown it maximum oxidation state in 3D series. Tell me 30 seconds. What was the highest oxidation state in 3D group? In 3D series, what was the highest oxidation state?
Plus 7.
Which was shown by which element?
Manganese.
Okay, manganese. But I don't see any compound of manganese here in plus 7 halide. MnF7 is not there. Not there.
Yes, sir.
Okay, there was question on this. It is not there. Now you will answer. It does not exist. So it is clear when highest oxidation state, fluorine is the strongest oxidizing agent.
Yes, sir.
but still it is not forming plus 7 with manganese, not forming plus 7 with manganese.
Yes, sir.
They are quite difficult because you can see that with manganese plus 7 will be very small in size, very small in size, and stabilizing with 7 fluorine will be
It would be crowding, which is not
sterically it
possible.
will
Yes,
not be
sir.
possible, so it not forming anything like plus 7 out. All right, student. So far, so good. Okay. Second thing, I see plus in the titanium. In the case of titanium, student, you are seeing TiX4, TiX3, and TiX2. So you are getting titanium tetrahalides. If I say TiCl4 or Ti, actually higher oxidation states are expected with fluorine, and you are getting TiCl2 or TiX3 also. And in the case of vanadium, you can see there is a penta FVF5 also.
Yes, sir.
VF5 has been written now, but others VX4, VX3, and like this have been written. That means the plus 5 oxidation state is existing with fluorine. That we already know the answer. You see, what fluorine is the strongest oxidizing agent.
Yes, sir.
So this is able to produce plus 5 oxidation state.
Okay.
So these compounds show plus 5 oxidation state only, plus 5, and other halides undergo hydrolysis. Others halide undergo, if I say VCl5, no, VI3, no, they undergo hydrolysis. Other VX5 will undergo hydrolysis. And what will they form? If hydrolysis, they will form something like a VOX3. What do you mean by
Yes, sir.
VOX3, student? It is clear, VOCl3, something like that.
Yes,
So
sir.
oxygen, what is the interesting thing here? Oxygen has replaced two halogens because oxygen can form multiple bonds. You know that?
Yes, sir.
It forms a double bond. Oxygen forms a double bond, students. So it will replace two halogens because they are not becoming stable. They are not becoming stable. The size is becoming large. The size is becoming large. The size of fluorine is small. Size of fluorine is small. As you see that higher oxidation states are going to be ionic, uh, covalent. Higher oxidation states are going to be covalent. Lower oxidation states are going to be ionic. That is another thing which we have already told you, student. Yes or no?
Yes, sir.
Okay, so far so good. Let us see the surgery of the table which is given to us. Surgery of the table. Whatever is given to us, data, this is experimental data, so I have not created it. We must try to understand and explain to it if possible. Sometimes we may not have a proper explanation, then that question is not going to be there for the course. Got my point? We don't have explanation for
Yes,
everything.
sir.
In nature, so many things are existing. How much explanations we can give, whatever chemistry we have learned, student, based on that. If you can find an explanation, you can give to me. If it will be based on some fundamental concept, I will accept it. Doesn't matter. Even you can produce an explanation. Got it? How
Yes,
will
sir.
you produce an explanation unless you will think you cannot produce an explanation? So if I see chromium, in the case of the chromium, what you are seeing, student, you come up to chromium again. For the chromium, you are saying you are getting plus 6 also. Again with fluorine, and for plus 5 also with fluorine, and then CrX5 means with other halogens also you are getting these, so in the manganese you don't have anything. Manganese plus 5, you don't have that. Only Mn4 plus 4. So manganese is forming Mn4 and Mn3 and MnX2. Mn4, keep on talking with me.
Yes, sir.
MnF3 and MnX2 means that Cl2, Br2, I2 can be there.
Br2I2. Yes, sir.
So the lower oxidation states are ionic, higher oxidation states are covalent, students. So beyond manganese, what is happening? Only plus 2, plus 3, plus 2, plus 3. For iron, what you have? 3 plus and 2 plus, that
2
is
plus.
FeCl3 is known, FeCl2 is also known as per this. So you have, but this is more Fe2 plus may be oxidized to Fe3 plus. These are the trihalides. These are the trihalides. The question was the highest oxidation states are with fluorine. So that one of the reason you already know, there will be higher lattice energy.
Okay.
Higher lattice energy. You have heard about lattice energy?
Yes, sir.
What is that, students? Lattice energy. I'm talking about lattice energy. So it depends on the charge by charge and the radius ratio. Higher the charge, smaller the radius, more is the lattice energy, students. So that is important when compounds are formed. And if you have to break them also, then that much energy has to be supplied. So higher the lattice energy, and in the case of cobalt, you see what you find, student. You are finding in the trihalides the highest oxidation state is more stable with fluorine. You are saying Fe x3 and COX3. The higher oxidation state is more stable because there is a higher lattice energy. There is a higher lattice energy. Or what we can say that in COF3, student, there is a higher bond enthalpy. Higher bond enthalpy. What is the bond enthalpy, students? Higher bond enthalpy is there in VF5 and CRF6. Lattice enthalpy and bond enthalpy, student, because they are covalent compounds. Higher oxidation states are covalent compounds.
Covalent compounds. Yes, sir.
So the stabilizing factor, where we have been talking about these things, students, when solid compounds or other compounds are formed, ionic compounds are formed, we have been talking about lattice energies in CF3 and FeCl3. That if the lattice energy is more, they are going to be more stable compounds, more stable oxidation states, students. All this
Okay.
we observe, student. All this we observe. And interesting thing is that question could be there in the case of copper, student. Where is copper? You have CuX2 and
O and
CuX.
CuX.
Now, what is this CuX2 and CuX? What is this CuX? If I say CuI, student,
Cu.
how will I say CuI? This is written as Cu2I2.
Okay.
Cu2I2, student, and you have CuI2. What is the oxidation state of copper in Cu2I2, students?
Oxidation state of copper in Cu2I2. Okay. It will be +2.
How? This is 2x minus 2 equal to 0. So how it is plus 2?
+1. It will be plus.
Cu2I2
Okay.
copper plus 1.
+1.
What is here? This is plus 2. ठीक है? This Cu2I2
Okay.
is plus 1, student, and CuI2 is plus 2 oxidation state. And this copper 2 plus can oxidize iodide ion. So see, the important reaction was given somewhere in the paper. All right, just a second. All right, this you have already noted down what type of questions are there.
Yes, sir.
Okay, wherever a question is possible will be discussed in this class. Okay, students. So together we are working hard for finding out what is happening, student. What I am saying, what was is that copper 2 plus, copper 2 plus, it reacts with iodide ion. And now you have to write the reaction. Write the reaction, student. This this 2 plus actually what happens is can oxidize. If it can oxidize mean it will get, I am saying
Reduced.
copper 2 plus can oxidize. What will happen to copper 2 plus?
Reduce.
Plus 1. Plus 1. So what will be the, then if it goes from 2 plus 2, what will be the product, student? What will be the product? Can you
Uh,
write the product?
it will be Cu plus I2.
I2. Okay. That means, student, this is minus 1 oxidation state. This is 0.
0.
And what you are getting, Cu plus. Cu plus. ठीक है? 2
Yes,
I
sir.
minus, 2I minus. Cu plus. Or what happens actually, what happens is that you get Cu2 plus. Cu2 plus is what was that? Cu2 plus Cu2 plus, students, Cu2 plus, or I say Cui2. Cui2 reacts with I minus and it gives you Cu2I2. Cu2I2 plus iodine. Plus iodine. ठीक है? What will be this? 2 and 2, balance it. If I have to Cu2, because it becomes Cu2, how many are these? 2 and 2, 4. So 2I2. See? So what has happened?
Yes, sir.
Copper, what is the name of this? This is called cuprous.
Okay. Yes,
Cuprous, I told you, OUS is
yes,
used
sir.
for a lower oxidation state.
Yes, sir.
Cuprous
Yes, sir.
iodide.
Cuprous.
And what will be this? Cupric.
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 Sometimes in the exam they only talk of names, they do not give the formula, so we should be careful, students. So copper 2 halides are known including CuF2. ठीक है?
Yes, sir.
But actually what happens, students, this compound is not known usually.
Okay.
Not known. I'm just trying to see that cupric means this cupric. CuF2 is known. But in any case, because it's a plus 2 oxidation state of copper, plus 2 oxidation state of copper. So it is that this is known. This is known. Cuprous iodide is known, students. So uh, so what we are trying to show you that plus 2 oxidation state of copper goes to plus 1 oxidation state. And another important reaction is known for copper. Copper 1 compounds are unstable in solution. Compounds are unstable in solution. They are unstable in solution. Why? Question why? Question again, question for us. Copper 1 compounds are unstable in solution. What happens to them? This question was asked in the paper. If you have copper plus 1, student, what happens? It forms copper and copper 2 plus. It forms copper and copper 2 plus, students. What type of reaction is this? Important reaction, student, important reaction.
Sir, this is disproportionation.
Disproportion. That's why I said disproportionate reactions are always important. Anytime question can be there. This is example of, so copper plus 1 are unstable because they're disproportionate. They disproportionate, students.
Okay.
Which one disproportionate? Copper plus 1.
Copper plus.
It will go to copper 0
0 and copper
and
2
plus 2.
plus.
This is plus 1 oxidation. Say important question, important question. So I hope we have been able to understand the halides. And what are the trends in the stability of the oxidation states of different 3D series. 3D series, what we are talking is 3D series, students. Most of the questions we are talking are of 3D series. Okay, so we can proceed further, students. We can proceed further. This lecture is very important. There will be at least 1 or 2 questions in the paper. Very important questions are coming, students. Further, now I am talking of, students, I am talking of oxides of the transition elements. Oxides of the transition elements. ठीक है? But
Yes, sir.
mostly we always discuss, students, the 3D series. What I am discussing all the time, student, is 3D series.
3D series.
Usually what happens, these elements will react with oxygen, and on heating they will form the oxides. They will form the oxides. So they will form the oxides. The highest oxidation is the same as the group number. In what will be the highest oxidation state? It will be the group number. Group number. So I am saying, student, tell me the oxide of scandium. Scandium.
For scandium,
What is the oxidation state of scandium? Now I'm again asking you to scratch it.
scandium is +3.
Only +3.
So
Anything
yes.
else? Scandium seen you there?
No, no,
No.
sir.
So many times question has been asked.
Sc2O3.
And 2 minus. So what will be the formula then?
Hc2O3.
So you will multiply this by 2, you will multiply this by 3. Same method of finding the formula, 10th class chemistry. Even students don't know
Yes, sir.
that. So Sc2O3.
O3.
This is a +3 oxidation state of scandium, student. So in the scandium, you are getting +3 oxidation state, which is a maximum oxidation state of possible for scandium. And in the case of titanium, you see what we are getting, student. You don't have oxides of higher oxidation state. You are getting titanium. You are given TiO2, Ti2O3, and TiO. This is a list of the compounds which exist, student. Exist, student. So we not making it. They have been existing in nature. So if they are existing, we are talking about them as per the list given in the NCERT book. The table has been taken from NCERT book to understand what is the meaning of this. What happens to vanadium, student? Vanadium. So vanadium, we how many oxidation state? It is also, see, vanadium V2O5, and you have V2O4,
V2O3.
V2O3, and VO.
VO.
So how many oxidation state it is showing?
4.
What
4.
is the oxidation number here? +5,
+5, +4,
+3,
+3, and +2.
+2. So vanadium is able to form oxides in this, and there could be some oxocations or oxoanions also. There could be some oxocations or oxoanions also. Depends. So what happens, student? What is the important point in the chromium? Chromium. What is the oxidation state of chromium in CrO3?
In CrO3, it will be +6.
Chromium +6. This is the highest possible oxidation state.
Yes, sir.
So highest oxidation state is nothing but the same as group number. So chromium +3, chromium trioxide is known. CrO2 means, but chromium is in +4. And what you have? Cr2O3. Cr2O3. What is the oxidation state, student?
In Cr2O3, it will be +3.
+3, and CrO +2.
+2.
All are known. Important point to note is that you are having Mn2O7. What is the oxidation state of manganese in Mn2O7, student?
Mn2O7. 14 +7.
+7. So question paper has been asked in the paper. Then what is the question, student? Manganese plus 7 in Mn2O7, but MnF7 no. This is not existing. This is existing. Again, I said, what is the answer, student?
Sir, because MnF7 is not stable because F cannot form double bonds and
You
O
don't
can
have to
form
write anything
multiple
about a double
bonds.
bond in the case of fluorine. That we know already. Only
Okay.
thing is you have to explain this.
It is theoretically not possible.
What answer I am writing?
Ability of oxygen to form multiple bonds. Okay.
That's all. I am not talking more than that. I don't have to write unnecessarily. There is no need for that. Only 1 mark. These questions are only 1 mark, carrying 1 marks, and the paper. Now I have said okay. He said another question. Draw the structure of important questions. I am talking. Mn2O7. Mn2O7. Draw the structure. You have 1 minute, student only.
Mn2O7. Okay. Yes, sir.
Actually, what is happening? You have Mn. How many oxygens?
Uh, One is U6, three each.
Each manganese is tetrahedrally surrounded by how many oxygen? Four.
Four.
Four oxygens. You can see that. And now 2, 4, 6, and 7. Covalent bonding. Covalent compound, student. Covalent compound. ठीक है? These are covalent compounds, student.
Yes, sir.
This is important question because here we have seen this. There's nothing like that anywhere. And then there are other oxidation state of manganese, MnO2, Mn2O3, and Mn3O4 also is existing. Important thing. What is the oxidation state of in MnO2, student? MnO2. What is the oxidation state of manganese?
MnO2 plus 4.
And in Mn2O3
Plus 3.
plus 3. And in Mn3O4
Mn3O4 it will be plus 3 only.
how plus 3?
No, plus 3 कैसे होगा? Plus 3 कोई होगा.
Calculate. Important question for the paper. That's why I have taken it, student. Otherwise, I will not take it. This question has been asked. What is the oxidation number of manganese here? How do you
It will
calculate the
be
oxidation number? 3.
Mn3O4 it will be plus 2.
How it is plus 2? 3x minus 8 equal to 0. What is x? X, students?
8 by 3.
Plus 8 by 3. Now the trouble starts.
But oxidation number cannot exist in
Then
fraction.
that is why the question was asked in the paper, students. You got my point. Why did I take this? So how do you
Okay.
explain this, student? How do you explain this, student? Do you have an answer to this, student? Think about it. I'll give you 1 minute only. This question was also given in medical, medical student. 4 marks. Either you get right or you get zero. You have only 1 minute. Something is important here. I hope you understand why I discuss everything in the table.
Yes, sir.
Okay, you have an answer, yes or no. See, the story is like this, students, that this compound actually exist in a different form. It is not a, this is the average oxidation number. If you are getting student, I'm saying MN3O4, you are saying M manganese is plus 8 by 3. This is not a, this is called average oxidation number. If you have something, some idea of oxidation state in 11th class student, we told you this is average oxidation number. Average oxidation number means there is some, the structure of this is not like what it is existing, student. If I write it like MnO, how much is left? Mn2O3. If it is something like this,
Yes, yes, sir.
then what is the oxidation state of manganese in MnO
In
plus 2?
MnO2 plus 2
In Mn2O3, what is the oxidation state of
plus
manganese?
3.
Plus 3. 6 plus 3. Is it the formula? Okay, 2 plus 1, 3, 3 plus 1, 4, plus 3, plus 3. So what will be the total average of this? What is the average of this? Plus 2,
Plus 2 plus 3.
plus 2, plus 2 into plus 3 divided by 2. How much is that?
So it will be 26 plus 2, 8, 4.
Huh?
And 4 new. You can plus 2.
2, 6. Now there are 3 manganese, now. Plus divided by 3.
3 it will be.
So
3,
what is
yes.
the formula coming now?
It will
How many
be
manganese? 2 and 1, 3. Average
8 by 3.
plus 8 by 3. So that means actually we can write that actually this compound Mn3O4, student, MnO4, it is existing. It is actually contains MnO and Mn2O3, MnO, Mn2O3. Got it?
Yes, sir.
Then I can explain its oxidation number. Then I can explain its oxidation number. This was a story of this. Did we answer the question now?
Yes, sir.
Okay.
Okay.
All right. All right. So, what is the oxidation state in MnO? That is plus 2 and minus 2. Okay? And
Yes,
you
sir.
know that if you have Mn7 plus, then this state will be, it will act as an oxidizing or
Oxidize.
reducing.
It will act as an Mn plus 2.
It gains 5 electron. It goes to Mn2 plus. Mn2 plus is a stable oxidation state of manganese. Yes or no?
Yes, sir.
What is that? D5?
D5.
Okay, then it will act as a strong, they are strong oxidizing agent.
Oxidizing agent.
You already know that in chemistry lab you are using KMnO4. What is that? MnO4 minus.
Yes, sir.
MnO4 minus acts as an oxidizing agent. Acts as an oxidizing agent.
Okay.
You are aware of that. You are aware of that, student. Now, question answered. Question answered. What is the oxidation state of iron in Fe3O4?
Fe3O4.
Hmm.
It will be maybe 3x minus 8 is equal to 0. It will again be 8 by 3 only. Average oxidation number.
Uh, it is plus 8 by 3. This is the average oxidation number, student.
Yes, sir.
Then how will you explain it in exam? Then what is Fe3O4 is not actually Fe3O4. Then what it is? You have only 30 seconds to answer the question, student. You already have answered the question. We have shown you so much clearly everything.
Okay. It will be Fe3O4. It will be FeO dot Fe2O3.
Okay, now you can find the average of this. You said it is average. Find the average of this, student. Find the average of this. What is the value coming? What is the
Uh,
value coming?
Average will be 8 by 3. Value is coming 8 by 3.
All right. This question was given somewhere in the paper. Carrying 4 marks for the competition. You got it?
Yes, sir.
All right. Can see that how important questions are given. Okay, then I am coming to the last question of the oxides, students. So far, we have been able to answer so many questions. Now, if I see this oxide also, I have got it. Another oxide is coming, CO3O4. CO3O4. ठीक है?
Yes,
Oxidation
sir.
number of cobalt. Explain. Explain, students. You have 1 minute to answer the question.
Cobalt, it will be CO3O4. In CO3O4, again, oxidation number of cobalt will be 8 by 3, and we can express it in this way only.
This is our average oxidation.
Average oxidation number. So it exists as CO O dot CO2O3, CO2O3,
ठीक
and
है?
then we can calculate average. Yes, sir.
All right. Now you got the answer. All right. So we got this. Nickel only. Nickel is showing only +2. Nickel oxide only +2.
Yes, sir.
But copper has which two oxidation state? Copper is showing +1,
And +2.
+2. You know which is more stable oxidation state of copper?
+2.
Zinc shows only one oxidation state.
+2.
Why? Why? Only one oxide. Zinc form only one oxide. Why, student? Every time there is a question, student, for you. Only one oxide. Why? What is your answer? Zinc form only one oxide. You already know this answer. What is so important?
Zinc shows only one oxide because
What is the oxidation state?
it has fully filled d orbital 3d10.
3d10. Zn2 plus is 3d10. Therefore, zinc form only one oxide. Stable configuration. Zinc shows only one oxidation state. Students, I hope that you have been able to answer large number of questions on halides and oxides and is expected question in the paper. There will be question on halides and oxide, but what question now you have such a wide variety and have been able
Yes, sir.
to do the complete surgery of all these tables which are given in the books. So I hope we understood most of the things. These data is taken from the book or literature, which is based on the experimental facts, which whatever they have. Our attempt is to explain these various oxidation states and their stabilities and giving reasons. Wherever we see some different anomaly, then we have to explain it. Okay, then I hope we have completed both these topics, student. We will continue further. This topic is over, which was the most important part, the reactivity, electrode potentials, halides, oxides of 3D series. Questions are always given on these topics. They are very important. Okay, good night,
Yes,
student.
sir.
Bye bye. Wishing you a very happy Diwali, and
Happy Diwali, sir.
we'll see you in our next class.
Okay, thank you, sir.
Okay,
Happy Diwali, sir.
happy Diwali to all of you.